Okay, good morning. Welcome to
FamilyMath number 444.
FamilyMath444. So we're gonna revisit an old project that we've done with dominoes today. Just to revisit some basic ideas about proving things.
Okay.
Okay. So we've got our bunch of dominoes. We probably have 100 dominoes. But the fact that the numbers on them aren't going to matter today. All that matters is that they are 2x1 rectangles.
Okay.
Okay. So we can break them up into 2 1x1 squares.
Okay.
All right. And so what we want to do is see, we're going to try to count the number of ways we can tile a 2x(n) rectangle. So it's 1 across the top, 2 there. So this would be one way we could tile a 2x4 rectangle.
You can't go 3x4. It has to have 2 by something.
Yeah, it has to be 2 tall, and then it's going to be n wide, and we're going to look at n equals 1, n equals 2,
N equals 3.
n equals 3, n equals 4,
And so on.
all the way up. And we're going to see if we can see a pattern. And if we do see a pattern, we're going to see if we can prove why that pattern is true. Okay?
Okay.
So you guys get the problem?
Yeah. Sure.
All right. Why don't you get out a few more dominoes, and you know what I'll do? I will mark with the keyboard here where the side is. The sides of the screen's over here, and actually the keyboard goes roughly from the bottom to the top of the screen.
Okay. So.
And so it looks like it's basically the edge of the table over here. So that's where you got to stand. All right. So how do you want to get going with this problem?
Well,
So we can start with a 2x1.
Uh-huh.
Just that.
yeah. Or
All right. So what does that mean?
Well, there's only one way to tile a 2x1 rectangle.
There's only one way to tile a 2x1 rectangle. Okay. All right. That's a good case to start with.
so then we could go to the 2x2. Yeah.
Okay.
So you could have something like this.
Or you could have something like this. And they're not the same.
No, they are definitely not the
Because,
same.
Yeah, this one's rotated on its side.
Okay. So what?
So we
Do
have-
you see a pattern yet?
Well,
It's
we go
just
1, 2. That's not much
There's
to
lots
go
of
by.
possible patterns.
Okay. What's one thing that might come next if that?
Well,
4, or just 3 maybe.
Okay. Could be 3.
could be 4.
What would the 1, 2, 4 pattern be?
Powers of
Either
2.
powers of 2 or you're doubling every time. So, well, that's powers of 2 and doubling are the same thing.
Well, when you start with 1,
Yeah.
it's the same thing. If you start with 3, that would be the same thing. So you're right. Technically, those are different. In this case, they're the same because you started with the power of 2. All right. Let's go to
3. 2x3.
2x3.
Well, we could do.
Actually, if we don't do it systematically, you'd start with it like this.
And then. So. We could make something like this. Here. And only put that in the middle.
And then we could make this.
Okay.
Or anything else. I need more dominoes.
No, I don't think so.
Do not think there's anything else.
All right. How do you know? Or give me an argument for why there's not another one.
Well, because we started with this, and then we were looking at pairs that we could flip, like
Okay.
that. But there aren't any other pairs that we can
So you
flip.
can't go like that.
That doesn't work.
Okay. Interesting.
Well, now I'm just going to point out that if we look at a 2x0 rectangle,
Uh-huh.
there's one way to tile it.
Ah, it's always sneaky to look at when there's a 0 rectangle or a 0.
So
Why is there one way with a 0 rectangle?
because the one way is to have no tiles.
Okay.
So
So
1, 1, 2, 3.
So I'm sensing Fibonacci.
Okay. What's another way? A different way the pattern might continue. here?
Well, we could just go 4,
Okay. So maybe the Fibonacci numbers are hiding here.
or maybe just 1, 2, 3, 4, 5 up.
1, 2, 3, 4. Okay. So tell you what, you got these here. We'll keep these together over here, and then you can do the 4 one next. Okay. So
Okay.
you can pull some tiles out too while the
Okay.
camera's off.